matrices have a wide range of applications and may be used to solve real-world problems, making them a vital idea for solving many practical applications. Mathematics behind Google PageRank is nothing but matrix and its transpose. The ranking of a page is based on an algorithm called PageRank used to rank web pages in search results. It is based on a massive spreadsheet. All of the web pages are listed in the rows and columns of this spreadsheet. It is important to know more about the theory behind it, and that is nothing but the transpose of a matrix. Transpose of a matrix. Suppose we have a matrix A of order m by n. Matrix A is defined as A is equal to Aij. If we interchange the rows and columns of matrix A, we obtain another matrix which is called the transpose of a matrix. Transpose of a matrix is defined by Aj of order n by m. That means rows of matrix A become the columns of the transposed matrix and columns of matrix A become the rows of the transposed matrix. It is denoted by A dash or A superscript T, and it is read as A transpose. Hold on, have you noticed something particular? The order of the matrix has changed when it undergoes an interchange. This is the only feature that changes when we transpose a matrix. Alright, now let's see one example for better understanding. Matrix P is equal to minus 6, 8, 3, 3 by 4, 5, 0 of order 2 by 3. Now take your own time to find the transpose of matrix P. Remember, the rows becomes the columns and the columns become the rows. So what will be matrix P transpose? P transpose is equal to matrix minus 6, 3 by 4, 8, 5, 3, 0 with the order 3 by 2. Let's now go through the properties of transpose of the matrices. A dash, the whole dash, is equal to the matrix A itself. Second property, K into A, the whole dash, is equal to K into A dash, where K is any constant. Third property, A plus B, the whole dash, is equal to A dash plus B dash. And the fourth property, A into B, the whole dash, is equal to B dash into A dash. Next, we shall discuss the two special types of matrices related to the transpose of a matrix. And they are skew-symmetric matrix and symmetric matrix. Let's discuss it one by one. The first one is symmetric matrix. A square matrix A is said to be symmetric if A dash is equal to A. Note, we need a square matrix to satisfy the condition for a symmetric matrix. Now, when you get a question, how will you identify whether the given matrix is a symmetric matrix or not? Here is a flow chart. Suppose you are given a matrix A. The first step is to find the transpose of the given matrix. The second step is check if A transpose is equal to A. Now, if they are equal, we can say the given matrix is a symmetric matrix. Else, you can say the matrix is not a symmetric matrix. Consider, for instance, matrix R is equal to minus 8, 7, minus 3.2, 7, 2, 1, minus 3.219. Identify whether the matrix R is symmetric or not. What you will do? You will first find the transpose of the matrix R, and we get the transpose of matrix R as R transpose is equal to minus 8, 7, minus 3.2, 7, 2, 1 and minus 3.219. with the order 3 by 3. Now compare this matrix with the original matrix, and we have seen that R transpose is equal to R. Therefore, the matrix is a symmetric matrix. Alright? Identity matrix and zero matrix also falls under this category. Next, we will discuss the second type of matrix, that is skew-symmetric matrix. A square matrix A is equal to Aij is skew-symmetric if A transpose is equal to minus A. That is, Aji is equal to minus of Aij for all values of I and j. Now, if I is equal to j, we can write Aii is equal to minus Aii. Now, bring it to the other side, we get 2Aii is equal to 0. And we get finally Aii is equal to 0 for all values of I. That means the diagonal elements are all 0 in the case of skew-symmetric matrix. Let's see one example. Matrix Q is equal to 0 minus 2 minus 5, 2 0 minus 7, 5 7 0. Identify whether the matrix Q is skew-symmetric or not. First, find the Q transpose, and we get Q transpose is equal to 0 to 5 minus 2 0 7 and minus 5 minus 7 0 of the order 3 by 3. Next, find the negative of the matrix Q, that is, we get minus Q is equal to 0 to 5 minus 2 0 7 minus 5 minus 7 0, and we can see that Q transpose is equal to minus Q. Therefore, the matrix Q is a skew-symmetric matrix. Now, we are going to discuss some important results of symmetric and skew-symmetric matrices, which is stated in the form of theorems. Theorem number 1. For any square matrix A plus A transpose is a symmetric matrix and A minus A transpose is a skew-symmetric matrix. Let's see the proof one by one. Let B is equal to A plus A dash. Now B dash is equal to A plus A dash the whole transpose. We get A dash plus A dash the whole transpose. What is the reason? A plus B the whole transpose is equal to A transpose plus B transpose. Now we get it as A dash plus A. What is the reason? A transpose the whole transpose is nothing but the matrix A itself. Again, we can rearrange it as A plus A transpose. Reason? A plus B is equal to B plus A, which is equal to B. Alright, therefore B is equal to A plus A transpose is a symmetric matrix. Now let C is equal to A minus A dash. So C dash is equal to A minus A dash the whole dash, which is equal to A dash minus A dash the whole dash. We get it as A transpose minus A, which is equal to, taking the minus outside, we get minus of A minus A transpose, which is equal to minus C. Therefore, C is equal to A minus A dash is a skew-symmetric matrix. Reason? C dash is equal to minus C. Alright? Let's see the second theorem. Theorem number 2. Any square matrix can be expressed as the sum of a symmetric and a skew-symmetric matrix. Let's see the proof. Let A be a square matrix, then we can write A is equal to half of A plus A dash plus half of A minus A dash. How? From theorem number 1. We know that A plus A dash is a symmetric matrix and A minus A dash is a skew-symmetric matrix. Now, for any matrix K A the whole dash is equal to K into A dash, it follows that half of A plus A dash is a symmetric matrix. and half of A minus A dash is a skew-symmetric matrix. Thus, any square matrix can be expressed as the sum of a symmetric matrix and a skew-symmetric matrix. Hence, proved. Now we have learned transpose of a matrix and special types of matrices and their results. Transpose of a matrix is used when finding the inverse of a matrix, which will be discussed in the coming video. Now let's do a quick recap of what we have learned.
Manorama Horizon. Learning made simple.